Hello and welcome. Okay, so today, right now, whatever day this is that you're listening, watching, we're going over page 486, number 16. Page 486, number 16. Now, please notice that this question is the last question in the math section, which means it's supposedly the hardest question. It's definitely one of the harder questions. The math sections increase in difficulty from easy to hard. Alright, so it says, on a square game board that is divided into n rows of n squares each, immediately, without even reading anything further, I'm trying to represent what I'm reading, get a grasp on the situation. So this is n by n. There are n, it's a game board, a square game board, n rows of n squares. So there are n rows of n squares. K of the squares lie along the edge. So these squares are K. Which of the following is a possible value for K? Alright, so as a general rule, you want to try to make equations in the math section, right? Make equations. So I've got two. Come on, brush size, you got this. I've only got two variables, n and k. So I want to try to express k, which is the amount of spaces along the edge using n. So my k equals what? Now let's take this step by step. I know right along this top row, let's visualize this, right? It's a row and it's broken up into n squares. So along this top row, right here, I've got n squares. What else? The bottom row, along the bottom row, I've got how many there? You guessed it, n squares. Now it's unfortunately not as simple as just adding n squares along either column on the left and right. Why not? Because I already counted this square here in this end, and this square here in this end. So before I add this n square pieces in this column, I need to subtract 2 from it, so I don't double count those two boxes. And then I do the same thing with this column over here, plus another n minus 2 squares. So if you do this math, it comes out to 4n minus 4. So k is 4n minus 4. Now, how do we determine which is a possible value for k? All you're going to do is you plug in these values, because k is the number of boxes along the edge. So that has to be a whole number. You can't have 3.5 boxes along the outer edge of this game board. So for example, A says, could 10 be a value for k? Could 10 be equal to 4n minus k? And by minus k, I mean 4n minus 4. Well, I'm going to add 4 to both sides. and I get 14 equals 4n. Then I divide by 4 and I get 14 over 4 equals n, which is 7 over 2 equals n, which is 3.5 equals n, and n, right? The number of squares in any one row or in any column cannot be a fraction. It has to be an integer. So a cannot be the value for k. This is a tongue twister. Okay. Let's see if I can remember which of these choices is the answer. So again, we're trying to figure out which of the choices could be a value for k, and it's based on the equation that we came up with for k using n. I think it's E, so let's try it out. So again, we know that k is 4n minus 4. I'm just going to write that down. K equals 4n minus 4. E says that, or asks us if 52 could be the value for k. So could 52 be equal to 4n minus 4? We add 4 to both sides and you get 56 equals 4n. I'll divide that by 2 just because I'm doing mental math. I don't want to get a calculator. 56 by 2 is 25 plus 3, 28 equals 2n. Then I divide by 2 and I get 14 equals n. N could, it makes sense for n to have a whole number answer, right? So this, it's telling us this board is 14 by 14, and therefore our value of k, 52, makes sense. The answer is E. Victory! We've got it. Again, I know this one is also confusing, but don't fret. It's supposed to be a hard problem, and it's one of the harder problems in this book, in my opinion. As always, any further questions, if this doesn't make much sense, please talk to me about it. Alright. Good luck. See you next time.